Morning students, let's continue with our topic standard deviation under the chapter measures of dispersion, where already you people have learned how to calculate standard deviation by discrete method under individual series. So today you are going to learn how to calculate standard deviation by shortcut method under individual series. So let's begin. The very first thing which you will learn is the formula of calculating standard deviation by shortcut method. So the formula goes like this: standard deviation equals to square root of sigma dx square upon n minus in bracket sigma dx upon n bracket close square. So this formula you are going to use to calculate standard deviation, and the data which has been given over here is the marks of 10 students. If you see, the marks goes like this: 8, 10, 12, 14, 16, 18, 20, 22, 24 and 26. Now I have made again a table in which it has 4 columns. On the left hand side is a serial number, and I have counted these marks which are actually x and they are 10. So I have taken 1 to 10. Our n is 10 and x is marks, and I have noted down as it has been given: 8, 10, 12, 14, 16, 18, 20, 22, 24 and 26. Now the third column is the column in which we have to calculate deviation. So to calculate the deviation, you people know very well that you need to assume a number, and you assume a number from x. Now already I have told you previously that you can assume any number which is divisible by 2 or which is the center number. So I have taken number 20, which is of course divisible by 2, right? So I have assumed 20 from x, and now I am going to take out deviation, and you know how to take out deviation, that is x minus a. So from the x we are going to deduct the assumed value. So the first is 8. 8 minus 20 comes to minus 12. Then we have 10 minus 20, that comes to minus 10. Then 12 minus 20 is minus 8. 14 minus 20 is minus 6. Then 16 minus 20 is minus 4. Then 18 minus 20 is minus 2. 20 minus 20 is 0. Then 22 minus 20 comes to plus 2. 24 minus 20 is plus 4. 26 minus 20 is plus 6. Now we will find out dx square. That means we have to double the value of deviation. So if you see, the first deviation is 12, and the square of 12 comes to 144. Then of 10 is 100, 8 is 64, 6 is 36, 4 is 16, 2 is 4, 0 is 0, then 2 is 4, then 4 is 16 and 6 is 36, right? This is how you have taken out the square of deviation. Now you add on all the deviation we have added, that is sigma dx comes to minus 30, because you know very well I have added all the minus together, all the plus together. When you add all the minus together and you plus together, then you deduct the value, as the value of minus is more, and that is why I have written minus 30, right? And sigma dx square, if you add all the values, you get 420. Now what we are going to do, we are going to put these values into a formula, which is square root sigma dx square upon n minus in bracket sigma dx upon n square. So your sigma dx square is how much, children? That is 420. Your n is how much? N minus, then sigma dx is how much? It is minus 30 upon n is 10 in bracket square. So when you calculate 420 from 10, you get 42, that is, and over here you know very well that it comes to the minus, that is, when you deduct minus 30 from 10, it comes to 3. So when you calculate 42 minus in bracket minus 3 square, you get a square root of 33. and when you find out the square root of 33, your standard deviation is 5.74. Now children, already I have explained you in my previous video how to find out the square root. That is how you make the pairs, and that is how you find out the square root. And this is how you can calculate standard deviation by shortcut method under individual series. Now we are going to learn how to calculate standard deviation by step deviation method under individual series. So children, again we'll go with the formula first. The formula for step deviation is standard deviation equals to, that is, square root sigma dx square upon n minus in bracket sigma dx upon n square into c. Children, c is a common factor. Already when you people were doing mean, at that time I've already explained you that how you people find out the common factor, but still I'm going to explain you again over here, so be very careful. Now over here again a data has been given, that is the monthly income of 5% has been given, and we need to find out the standard deviation, right? Now if you see, this is the monthly income of 5 people. The first one, he gets the 500 rupees, second one gets the 700 rupees per month, third one gets the 1000 rupees per month, fourth gets the 1500 rupees per month, and fifth gets the 1300 rupees per month. Now with this data we are going to calculate step deviation method through, that is, standard deviation. So if you see, again a table has been drawn which has a 5 column. On the left hand side I have taken the serial number which is 5, 1 to 5. Then monthly income I have taken as it has been given, 500, 700, 1000, 1500 and 1300, which is actually our x. And then the third column is, we need to find out the deviation. You people know very well how to find out deviation, that is x minus a. That means you have to assume a number from x, that is monthly income. So if you see, again I told you as that a number that is to be assumed has to be either a center number or a number which is easily divisible by 2. So I have assumed 1000 which is easily divisible by 2, and it's a center number also. So if we deduct x, that is 500 from 1000, we get minus 500. If we deduct 700 from 1000, we get minus 300. 1000 minus 1000 is 0. If we deduct 1500 from 1000 is plus 500, and if we deduct 1300 from 1000 is plus 300, right? Now what we have to do, this is the important step, that is the step of step deviation method. Now children, from deviation you need to find out a number which has to be a common number from which all these deviations are divisible. They all can be divided. So if you see, the deviations are 500, 300, 500, 300, and a common number through which all these are divisible is 100. And that is the reason I have taken C as 100, which is a common factor. So that means 100 divided by 5 is 100 5s are 500, 5. 100 divided by 3 is 3. Same again 100. If you divide 500 from 100 is 5. If you divide 300 from 100 is plus 3. So we got a common factor also. Now dx square. So you know, now this step has to be kept in mind, children. Now that square root has to be done from this common factor, that is the where we have taken out the dx, that is dx bar. So the double of 5 is 25, 3 is 9, that is 3 3s are 9, then 5 5s are 25, then plus 3 comes to 9, right? So now we are going to add all the dx square, that is sigma dx comes to 0, because if you add 5 minus 3, that is 8 minus 8. If you add plus 5 plus 3, again plus 8. So if you deduct minus 8 from plus 8, you get 0. And sigma dx bar 2, that is square, comes to 68. Now we are going to put this value into a formula. So your standard deviation equals to, the formula is square root sigma dx bar 2 upon n minus in bracket sigma dx upon n bracket close to that is square into C. So now we put the value 68 upon 5, that was our n, minus sigma d bar comes to 0 upon n is 5 into 100 because our common factor is 100. So if you calculate 68.5 minus 0.5, you get 13.6 into 100. So children, 13.6, if you find out the square root of 13.6, you get 3.6878. So if you add in this, multiply in this 100, if you multiply 100 with 3.6878, you get 368.78. that is, your standard deviation is 368.78. So this is how you can calculate standard deviation by step deviation method under individual series.